Yo, whoa, whoa, whoa. This is the kind of day where I really ask myself if it's even useful to do Leetcode problems anymore. Or even just in general be a software engineer. Or any white collar job, right? Any office desk job. I don't know if you guys had an opportunity to look at Chat GPT, but it's marvelous. It's so impressive that it's concerning. And this is really the first example of a technology in practice, at least that I've used. Now, there are other examples um, where it justifies the claim that in 10 or 20 years, most of our roles will be automated, right? That's something that a lot of people say. Right? People ring the alarm, there's going to be an AI revolution. A lot of these tech-based roles, technology-based roles, office-based roles, upper middle class roles will become obsolete. And that day is not today, but there's technology out today which justifies that day is coming soon. But that's not the topic of this video. I'm just a little bit concerned about my role going forward as a software engineer. What is that going to look like in 10 years? But it's okay today. That's why you max out your 401k contributions. And if worse comes to worse, you can just live on the streets. Okay, 1749, maximum absolute sum of any subarray. Okay, so you're given an integer array nums. The absolute sum of the subarray nums1, nums I plus 1, r minus 1, r, blah, 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 equals the absolute sum of those things. All right, return the maximum absolute sum of any possible subarray of nums. Note that absolute x is defined as follows. Yep, so, if it's negative, make it positive. If it's positive, keep it positive. Okay, so in this example, we have nums equal 1, -3, 2, 3, -4. And then obviously the maximum sum is 2 and 3. Okay. This example, we have nums equals 2, -5, 1, -4, 3, -2. The maximum sum is -5 plus 1 minus 4, -9. Okay. So how do we approach this problem? So what's difficult about me explaining this is that, like most strong Leetcode intuition, it's based on previous problems that you've already solved. And this problem is essentially identical with an additional aspect to a previous problem, which is how would you just find the maximum subarray within an array? And I would call it a greedy approach. Someone might say it's more dynamic programming. But let's just first ask the question of how would you find the maximum subarray within an array? Right, so not considering this idea of absolute, how would you find the maximum? Well, what you could do is when you look at a system of nodes, right, you could find the maximum subarray that you found so far and also the maximum current subarray at any index. So I guess if we looked at this example to find the maximum subarray, maximum meaning the highest value, right? Not the highest absolute value. So let's look at this again. And let's say there's an additional constraint here like this. Let's look at this example. So let's say that we had an n-time algorithm. There is an n-time algorithm. And we just process through from left to right each number. Is there a way that we could find the maximum such subarray? Not the subarray itself, but the value of that subarray. Okay. Well, if you encounter 1 and you haven't looked at any subarray yet, you could say, okay, well, my max subarray, we'll call that max sum, equals 1, right? Because all I've considered so far is 1. Now, if I consider -3 as well, well, 1 plus -3 is -2, right? So any subarray that's coming from the left that starts at 1, in order to get to this subsequent element, like, will you ever have all of these 3 elements together? Well, the answer is no, because if you add 1 and then you minus 3, you get a net of -2. So if I include this blue portion, I'm going to have to include a sum of -2. So that doesn't improve any subarray, right? If I'm this green node and I'm saying like, should I use the subarray to my left to create a maximum subarray? And then I look to my left and figure out, well, the only subarray, the maximum subarray I can get from the left is -2. I'm not going to include it, right? Because it's only going to lower my value. So I'm not going to use this information. So I could say like, currently I have this value of 1, right? That's what I can get to the left. But then once I encounter -3, I don't want to include that anymore. So I set current to 0. Now when I encounter 2, my new max sum is 2. And my currently is 2. Right? And then I encounter a 3. And now my max sum is 5 because I have 2 and 3. Okay? And then when I encounter -4, my max sum is still 5. But now that I've encountered -4, what happens to max curve? Well, now it sets to 1. Why not 0? Well, because now that this is 1, when I look from the perspective of this blue node here, 5, although 5 doesn't get a lot if it adds the subarray to its left, it'll definitely get at least 1, right? Because that -4 took away a lot, but it didn't take away enough to state that I don't get anything from the left. Does that make sense? Right? This system, this green system, is still able to provide me with a net benefit of 1. So if I use the subarray to the left, I get a net benefit of 1. So that means that this will become 6, and my maximum subarray is 6. So I guess we'll do this again and make it a little cleaner. So we'll process it again. And we'll change this to -8. And so let's do this again. But now I'm thinking, so we'll have this idea of max cur and max sum. And this is just the array. And then we'll process it like this one at a time. Okay, so when the array is 1, well, the maximum cur we've seen so far is 1, and our max sum is 1. When the value is -3, well, the max sum is still 1. Now, the max cur is the idea of what I can provide from the left, right? The subarray to my left that I can include, what's its value? Well, I can't provide anything positive, right? Because 1 minus 3 is -2, so the best I can provide is -2 to the left if I have to use -3. So that way, what 2 will essentially do is 2 will look at 0, right? It'll look at this information at the top and say like, okay, if I use my left subarray, what can I get from it? And this is saying the best you can get is 0, which is basically this system articulating like, if this is 0, that means that I can't provide you anything good, so you're not going to use me as a subarray because your value here is too small. It's messing with the subarray content, right? So now this is 2, so the max is 2, and this is 2. Now, when you go to 3, it asks its previous subarray, okay, what's the best subarray you can provide me with that I can use? And it says, oh, I can provide you with 2. And it says, okay, cool, I'll use that 2. And now my max cur is 5. Now -8 is like, all right, I'm super negative. Can you help me previous? And he says, it's 5. I'm like, okay, well, that's -3. So I would provide anybody to my right with -3. So I don't want to do that. So I'll just put 0 saying, don't use the left subarray. It's not going to provide you with any information. And the max is still 5. And then when you get here, It's 5. The max is 5. It can't provide, right? 5's like, all right, I'm a big value. Can you provide me anything to my left? Well, negative 8 is like, no, sorry, bro. I'm too small, so I can only provide you with 0. This is actually 5. So this idea will get you the maximum subarray. So in order to kind of write this in code, we'll just write that out first. So we have this max sum idea, which is the maximum subarray we can find, and max cur, which is this idea of, you know, what can I provide? What's the current subarray I can provide to the right, right? So we look at each num in nums, and the max sum will then be, well, we'll do both, I guess, at the same time. So max sum and max cur. Well, max sum will be the max of, well, what's the max sum we've seen so far? Because I'm trying to find the maximum subarray. So maybe previously I found a better subarray. Or the current max cur plus the num. So maybe the current value I have and what max cur gave me to my left. So maybe my value is 4 and max cur to my right is 6, right? So I have a subarray of size, not size, but like value 6 to my left, and I have value 4. So now my max sum is 10. And then we have to do the same thing with max cur, right? If max cur can provide you with something large, it'll give it to you. But if it provides you with something negative, that's only going to make your subarray worse. So don't include you. If I become below 0, just set me to 0, right? If the max cur plus the number that I am causes the subarray to become negative, it's not going to help anybody, right? It's only going to make things worse. If it becomes positive, it could potentially help somebody in the future, right? But if it's negative, it's not going to help anybody. So if it's negative, that's not going to help anybody. So just don't include me, which is what we articulate with 0. So this code will find the maximum subarray. Okay. Now, how do we integrate that into this solution here? Well, we're trying to find the maximum absolute subarray. So in order to have a maximum absolute subarray, the maximum absolute subarray is either going to be the most positive subarray we can find or the most negative subarray we can find, right? So again, it's either going to be the maximum absolute of something is either the most positive or the most negative, right? Because the most positive thing will stay positive and the most negative thing will turn into the positive, right? So whatever is the max of the most positive subarray and the negative of the most negative subarray is our maximum absolute subarray. So how about we just also do the same thing, but to find the minimum subarray. And finding that minimum subarray will find us the most minimum subarray, just like this other code found us the most positive subarray. And then we'll just take the max of both of those. So min sum, min cur, it's literally the same code, just with a little bit of not still plus, right? Because we're still adding in the value, and if the value is negative, min of min cur plus num and 0. And then at the end, we just return the max of, well, our max sum, which is our maximum subarray, and the negative of our min sum, which is our minimum subarray. And we submit that and we pray. Sometimes I just sit and pray. Sometimes I just sit and pray. Whoa, why is it so slow? All right, that's end time, so I don't know. Probably because I'm doing like the same operation twice in this, you know. Can someone explain to me why this is so slow? This is linear time. All right, it's linear time. I don't know what's going on with the system here. So what is the runtime in the... Let's not worry too much about this. We'll take a look at a comment. Okay, so what's the time complexity and the space complexity of this? All right. In the back of my mind, I'm just thinking about ChatGPT and how it would just automatically like do all of this and be like, whatever. So the time complexity, well, we have to look at each num and nums, and then we do a constant operation for each num, right? So that's O then. And then space complexity, well, we just have 4 kind of variables that we use to hold on to information about, the maximum subarray we've seen so far. So that's also just going to be, not also, it's going to be O of 1, right? Because there's just 4 constants here, some constants here, but nothing is scaling with the input. So O of n runtime, O of space time. And yeah, that's the solution. You could definitely make this. You can make this 3 lines. You guys want to see me do that right now? Because I hate myself. Watch this, man. I want to see ChatGPT do this. So hard. Man. Look at this 3-line solution. Unreadable code. There you go. There's a 3-line solution, and somehow it's magically much faster. So, again, this is not always something you should be too concerned about. Okay. Peace out, everybody.